Let's talk a bit about functions. With how much programming languages depend on math, it should be no surprise that, like math, we'll have access to functions. And so let's just do a quick refresher on what a function is. In math, you might expect a function to look something like this, where you have maybe f of x equals something like 3x plus 4. Or you might expect to have something else where maybe instead of just a number, you'll have something like g of v, where v is some kind of, let's just say, vector, and you might say 2v, and that's about it. And we could also have less rigid versions of functions, like just descriptions of problems in real life. And so one common example I think of when I think of that is you walk up to some kind of vending machine, and it has a bunch of stuff on the inside, and they have a little panel with the numbers, and you put in the money, and then there's a little door that the food falls out of. And so this is an example of a function, because a function is just something that has input and a unique output that's deterministic for that input, right? So here I might input some money into the little dollar slot, and then I might also hit some buttons on the little terminal on the right there. So we'll just say some kind of button combination. You hit A2 or B4 or something like that, and then what this outputs then is a snack, like chips or whatever it is. And so here, this is a function because it has input and it has output, and it's going to be unique output because if you put in $2 and then you press the button A2 and if it spits out a bag of chips, if somebody else walks up and puts in $2 as well and hits A2 on the buttons, then they're also going to get the same snack. So it's consistent in that every single combination of input here is always going to give you the same output, right? At least hopefully, assuming the vending machine isn't malfunctioning, it's going to do that. And so this is functional in that regard. And this is also a little bit different from the way that we've written these very simple math problems here, is that this has two separate inputs, and the inputs here are kind of different from one another. So the first one is probably, I guess you could say, a number because it's in dollars, so it's something with two decimals probably, and just a monetary amount. And then the button is something that you can press on the side, so it's probably a string that is maybe two characters, one letter, and a number. And the dollar amount is strictly positive. So there's some kind of domain to them, and they have a unique types, and they're a little bit different. We have multiple of them, and we can model that in a programming language as well, where we're able to do these unique things. Something that we should notice about all of these is that they have some common characteristics. Here, let's again take an example with f of x, so I'm just going to do f of xy in this case, just for an example. And let's just say I do 3x plus 2y equals, or not equals, there's no assignment here, it's just a function plus 4. And so we notice that this has a few things. So first off, it has a name. So the name of this function is f. We have some way that we can identify what the function is. We have a list of arguments that could be anywhere from 0 onwards, any non-negative number of arguments that we can plug in. So here I would plug in x and plug in y, right? If I was to use this function, I could say f of 2 and negative 1, and then I would plug in 2 for x and negative 1 for y, right? And then just figure out whatever number that is, which I guess would be, what, 8 here, I think? 6 minus 2 plus 4. Right? So we have, I guess let's leave this. We have this as well. So we can plug in things for x and y, and the order that I write them in kind of matters here, right? If I write 2 first, it's implied to be x, and I'll plug it in for that. And if I put negative 1 second here, then it's implied to be for y, and I put it in the same place. So we have that. We have this part, which is like a body, or it's some kind of operations that it's going to contain. And then we have maybe one other thing that's not obvious here, which is the fact that this is going to equal something. So it equals what I'm just going to call a return value, which has a type as well. And by that, I mean, in this case, we plug in numbers, so our arguments have types too. We're going to plug in two things, which we assume are numbers because that's something that makes sense for multiplication. I suppose that's really the only thing that would make sense here would be numeric types, because vectors wouldn't be able to add to 4. And then the return value is also a number, so whenever I evaluate this, I expect it to be some kind of number. Again, if I was to plug in 2 and -1, I think I got 8, which is also some kind of number, and whatever I plug into this, I expect a number out as well. So there's some kind of consistency to some extent of what kind of output we get. So we have an input, an output, a way to identify it via a name, and then a body which actually describes what the function does. And then on top of that, I suppose we also can use the function by simply plugging in values or variables or expressions or whatever into where the arguments go, the positional arguments. So we can use it, which I will say is calling it, and we'll get that in the future. We're going to be able to do all of these things in a programming language. Here, let's go ahead and try to write this up in C++. Now that we're over here in C++, let's go ahead and try to replicate what we basically just wrote with the f and the x and the y. We said that we're going to need some kind of return type, a name, a list of arguments, and then just the actual stuff that does the calculation. And so the way we do the return type is we simply put what we want it to be. Here, I think float would make the most sense. We want some kind of real value to be exported from this. We give the name next. In this case, it was called f. And then we give a list of arguments. And here, I'm going to put the curly braces as well. We're going to want to follow it with curly braces if we're doing a definition versus a declaration, which we will get into the difference between those in a moment, but for the time being, let's just do a definition. Here, I am going to say that it's going to take two floats. It's going to take a float called x and a float called y, and then we just want it to be able to give these back. The way we do this, whenever you want to make a function end and give a value, is with a return. So here we're going to return, and we said that the formula that we're going to try here was this 3x plus 2y plus 4. And so we'll try that really quick. We're going to return 3 times x plus 2 times y plus 4, and that's about all we need. And there we go. This should simulate our function. Let's go ahead and try this out in main really quick. So cout, and I'm going to call it with the same ones that we did earlier, which I think was 2 and -1 and end line. And here I will print a little message too, I guess. We'll copy this. We'll put equal and put that there. So I think we said this would be 8 earlier. Another thing to note here, it was something that we mentioned in our notes, is the fact that we need to be able to use this as well. So here I simply put the name of the thing that I want to use and then the arguments in the order. So what's going to happen here is 2 is going to go in here for x, and -1 is going to go in there for y. So if I run it, you'll see that we do in fact get 8, like I said. So f of 2, -1 is 8. And we have the ability to type in any kind of number here and be able to plug it in. And the same thing goes for variables as well. So I could simply set a variable equal to, I'm going to call it x, spelled out like that, to 2, and then I could pass that instead, and you'll notice that if I run it, I should get the same answer because it's just going to plug in 2, which is the variable for my call. And so that's our basic math explanation for this, kind of just how we want to format it. Let's get into some more of the technical details. Things to notice here are the fact that there are variable declarations now in our arguments. So here, when I give the name of the thing, I have created a variable that exists only in the context of that function. Here, when I create x, I actually don't have access to it anywhere else. It only exists in this function f, which is just the curly braces following it. Here, if I tried to say, well, okay, give me the value of x plus 7, you'll see that it says that is an error, right? So it underlines x in red and it says x is undefined. And that's because when I write x, it only refers to the scope in which it's declared. And so we should probably take a moment here to talk a little bit more about scope. Scope is going to be the place where a variable is alive or where it's able to be referenced. Here I can't use x because its scope, at least this x's scope, is only between these two braces where the function f exists. If I try to use it anywhere else, it's not going to work. That being said, if I do something like this, then that is totally fine. And so if I was to say x equals 2 and do that now, then it will recognize that x is a variable. One thing to note is the fact that this x that I just wrote down in main is not going to be the same x that's up here. They're completely distinct from one another. And to see that, let's go ahead and do this a little bit different. So I'm going to create a temporary variable called result just to store our answer in, and then I'm going to give that back. So this is just going to do really the same thing that our function did before, right? It's going to return the correct result. But what I'm going to do in between here is I'm going to say x is equal to x plus 7, and then I'm going to see out the x in my function is, and then I'll print it out, x, and then end line, and then we will print it up here. So I will see out x in main is, and then we'll end line, and I'm going to print x as well. And what we'll see is that the x's are actually going to be different. So as far as the execution of this code goes, right, it's going to start in main because that's what it always does. It's going to create a variable called x, set it equal to 2, and then it's going to go and try to do the code that corresponds with the function f, which is this stuff. And so we said, oh, it's going to pass x in as a variable here, but what we're saying is that whenever we create a variable, its scope is only the next curly braces that follow it, basically, or the enclosing curly braces that it's in. In this case, when you do it in a function, it's the function that it belongs to. And so when I try to do something like update x here, I'm going to add 7 to it, anything I do to this x is not actually going to happen to the x in main. Let's go ahead and run it, and we should see that that is the case. You'll see that we say x in my function is 9, but the x in main is 2. So even though I gave x as a variable to the function that I called, it doesn't reflect anything that happens in this function when it gets back to main. So the point I'm trying to make here is that this x and this x are completely different from one another. The x for the function only exists in the function, and the x in main is separate from that unless we do something special to be able to change that. And we'll get into that in a little bit. Another thing you may have noticed that I should probably just explicitly say is the fact that there's a bit of jumping around in our code. Whenever we do a function, what it quite literally does is it sees whenever you are using that function, when you give the name and the arguments, and it says, okay, I'm going to go jump to where that is in the code, and I am going to go there and basically fill things in. So when I run the code here, what it's quite literally doing is jumping up to line 8 from line 19. It's going to jump all the way up there, and it's going to fill in. It's going to say, well, x is going to equal whatever the x in main is. It's going to basically copy the value over, and then it's going to copy -1 into y, and then run this code. And then whenever you do a return, it just jumps back to wherever you called it from. Here, when I do this return result, you'll see it's going to come back to 19. Just for the sake of an example, I'm going to show this in Visual Studio because it's very nice at the debugger. It will actually show you the order that lines execute in your code. Here I'm just going to hit F9 on my keyboard. You'll see that it makes a little red circle over on the left. If you're using Visual Studio, you can do this too. And this is the main reason I'm having everybody use Visual Studio, is so that you can be able to pause the code like this. So this is called a breakpoint. It's just part of the debugger. You can use it to stop your code early. So here it actually stops my code. You'll see the little yellow arrow. It stops it right on this line. It's on the x equals 2 part. I can use this little arrow up at the top. Both of these actually work, the step into and the right arrow, and it will execute the next line. So you see here, it's going to try and print the stuff. And so if I click it again, boom, it jumped up to the top. The little yellow arrow moved up to float F. And so what it quite literally does is it just jumps up here, executes all of the code in the function, and okay, the C++ debugger is a little bit more about this. I can hit Shift F11 to have it go back to my program. I think it's actually just going to continue it, unfortunately. But what happens is it will, there we go, it will return back to main eventually. Apparently that was just something about cout. But you'll see after we do the return, it jumps back up here, and now it is back at the line that we called F from. So whenever you call a function, it quite literally does just jump around. Okay, well, we're on the topic of functions. Let's discuss one thing that's unique about the way that you write them in C++ and C that most other languages don't force you to do. And that has to do with the order that we write functions in. It's very common to put main at the top of your program, partially because it's the highlight of your program, right? It's the starting point, so it's common to just leave it up there. Unfortunately, C++ is not good with function names because of the fact that it only does one pass. The compiler only checks through one time. So here, if I was to move this function down to the bottom so that main is at the top because I want main to be my focus, I will get an error if I try to compile this. I just see a build failed, where it says identifier F is not found. And what that's saying is that it doesn't know what the function F means. And the reason it worked before, but not afterwards, is because the fact that my function beforehand was written before I used it. It's similar to the way where if I wrote this, where I said y equals 2, and then I wrote int y on the line after it, that this doesn't make a whole lot of sense because code is executed sequentially, and I need to make sure y is declared, and there's some sort of way for me to be able to know what it is before I use it. So this is invalid because setting y equal to 2 before it exists just doesn't make a whole lot of sense. In the same way, this is now saying I don't know what F is because I haven't encountered F yet, because C++ compiler only reads from top to bottom, and so now it's having a little bit of an issue figuring out what F is. The way we avoid this in C++, while still formatting it correctly with the function at the bottom, is to use what's called a function prototype. And what the function prototype is it's basically just the same thing as this. In fact, I'm just going to copy and paste it, and it's just semicolon. So there's no body to it. By body, I mean the part where the actual code lives. It's still giving me an error, but you'll see if I recompile, it should run perfectly fine again and does exactly what it did before. And the reason it is now, even though it doesn't know what F means, it at least knows that F exists. So you have to let it know what the names of all the things are that you're going to use before actually defining it. Again, this is kind of similar to what you can do with actual writing of code, where we could do something like this, right? Where I could say int x and then later define x equals 2, even though in the first line I didn't set x equal to any value when I created it. It's very similar here. You can create a function by just giving it its name and a list of arguments that it's allowed to take, and then you can define the function, basically explain what it is that the function is supposed to do later. One last thing to note about function prototypes is that you don't actually have to put names for the variables when you do a prototype. I can actually just put float, and it will let you fill it in later as well. But both ways work totally fine. Just consider, because this is an error I see a lot, you need to give variable names whenever you're writing the definition of a function. Here, where I'm actually writing the code for the function, I need to make sure that I put float x and float y. Putting float is not enough, because then what's your variable for float? What does that mean? There's no variable to be able to be used, so you actually need to give it a name in a similar way that you can't just put int on a line and expect it to know what that means, because int what kind of int are you using? Same sort of thing here. We need to be able to know what is the name of the two floats that we're using. In this case, I called them x and y. I think that's a pretty decent overview of functions. and we'll end up looking a little bit more in detail how we can actually modify the values that go into this. We can make it modify variables that we're able to pass, and how we can do things that don't necessarily need to return a value in the next video.